Assalamu alaikum. Welcome to the next video of Chemistry with Sarif Sambeg. In this video, we are going to cover heating and cooling curves. As the name suggests, it's a curve, so it has to be plotted on a graph paper. On the x-axis, you have time in minutes, and on the y-axis, you have temperature in degrees Celsius. Don't forget to label your axes when you're plotting a heating curve or a cooling curve. I'm going to specify in this case that this is a heating curve for ice. And we're going to see that what alphabets represent what state. So basically what you're trying to do is, as the time progresses and as you increase the temperature of ice, because we said that this is a heating curve for ice, right? So A to B, so we would say from A to B, it's a solid state. Solid state. Ice exists. From A to B, only ice exists. And the temperature is rising from A to B. So basically, from A to B, it's just ice in its solid state. But what is happening here is that as you're increasing the temperature, as we discussed in the previous video, the kinetic energy of the molecules increases and the water molecules in ice will start to vibrate faster. And as soon as this point B reaches, at point B, ice will start to melt. And hence I can proudly say that this is 0 degrees Celsius, because ice melts at 0 degrees Celsius. So this is 0. So at point B, melting starts to occur. Solid is changing its state into liquid. And from B to C, so this is basically this is the melting point of the solid, which is ice, and melting starts to occur. Now, the very important concept here is that we need to understand, why is this temperature constant? Why is temperature constant over here? Why is the temperature not increasing? I am increasing the temperature. I'm continuously increasing the temperature, but this increase in temperature is still keeping this temperature constant, which means that there's something happening from B to C, which is utilizing the heat I'm providing, which is utilizing or using the heat which I'm providing in the form of temperature. So what is happening? Of course, at point B, melting starts to occur, and I told you that melting occurs when the solid particles or molecules break free from their fixed positions and they weaken their intermolecular forces of attraction. So forces of attraction are being overcome here, and since they are being weakened over here, the forces of attraction, the temperature is basically used to weaken the temperature here is used to weaken the forces of attraction over here. So what you're trying to say here is that from B to C, temperature is increasing. I'm continuously increasing the temperature. Temperature is increasing. And this heat, the heat from the increase in temperature, and this heat is used to weaken the forces of attraction, and hence at melting the temperature stays constant. Again, I am increasing the temperature, which means I am providing heat. But from B to C, the temperature is not increasing. So the question is, if I'm providing heat, then from B to C, why is the temperature not increasing? Because that heat which I'm providing is used to weaken the forces of attraction in a solid, and hence the temperature is constant. Whatever heat I'm providing is being used up. So the temperature is not increasing and is constant from B to C. But once at C, melting stops. At point C, melting stops, because all the ice has been melted at point C. So from point C to D, from B to C, here you would see both solid and liquid. So from B to C, you would see ice and water both. And from C to D, it's just liquid. Because again, the temperature of this liquid is rising. And hence it's safe to say that point D is the boiling point of water. Because this liquid is just water over here. So at point D, this is 100 degrees Celsius. And this is the boiling point of water. So I can say C to D, temperature of liquid is rising. From C to D, temperature of the liquid is rising, and at point D, boiling starts. From point D to E, since boiling has started at point D to E, here you have liquid plus gas both. So you have like water and steam both at this point. But at point E, boiling stops. So you would say point D to E, water and steam will coexist. And after point E, so at point E, boiling stops. And point E to F, point E onwards, I'm just increasing the temperature of the gas. So the temperature of the gas is increased. Temperature of the gas is increased. The temperature of the gas is increased. So at this point, only gas, or you can say steam, exists from E to F. This is how we analyze the heating curve. Let's look at the opposite of a heating curve, which is a cooling curve. Now, this is a cooling curve of not steam. We're not cooling steam. This is just a cooling curve of some substance. So you can see that point A to B, it's only gas. At point B, you can say condensation begins. Condensation starts. Condensation is happening from point B to C. And here you can have gas plus liquid. Point C, condensation stops. Condensation stops. Point C to D, you have temperature of the liquid dropping down. So only liquid. D to E is basically your freezing. Your liquid is freezing. And you will have both liquid plus solid over here. And then E onwards is just solid. And the temperature of that solid is decreasing. In a heating curve, you were increasing the temperature, giving kinetic energy to the molecules. In a cooling curve, you are decreasing the temperature of the gas and you are taking out heat from them, which means you're reducing the kinetic energy of the molecules. Now, this is some cooling curve of a gas. And if they ask you what is the condensation point, now condensation point in other words is also known as boiling point, because boiling point and the condensation point is absolutely the same. Boiling point is from the perspective of a liquid, condensation point is from the perspective of a gas. But the boiling point or the condensation point of this solid will be the same, which is 150 degrees Celsius. So I can say boiling point or condensation point, both are the same. Boiling or condensation point here is 150 degrees Celsius. And similarly, this is the freezing point of a liquid, of this liquid, or you can say this is the melting point of a solid. It's the same thing. Freezing point from the perspective of the liquid or melting point from the perspective of a solid. Ek hi baat hai. And what's the melting point? 100 degrees Celsius. So this is how you can read the heating and cooling curves. They can ask you what state is existing at what phase in this diagram. They can ask you the heating, melting point, condensation point, boiling point, freezing point. They can ask you anything, and they can even ask you to sketch the curve when they can give you the data. So this is how we're going to analyze a heating and a cooling curve. In the next video, we're going to see the effect of temperature and pressure on the volume of the gas. So till then, stay tuned everyone, and thank you very much.